Figure 7.18 gradebook.java and Figure 7.19 gradebook-test.java. We're now going to look at our last version of the class gradebook, and in this case we're going to take advantage of two-dimensional arrays where every row represents one student and the columns in that row represent multiple grades for that particular student across a set of exams. And we're going to do some similar processing to what we did in the prior gradebook example in this lesson. Now I'd like to start out once again by taking a look at our test program. The gradebook test class contains our main method, and you'll notice here that I've hard-coded a multi-dimensional array, a two-dimensional array called grades array, and for each student I've provided a sublist representing 3 exam grades. And you can see that we have several different students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different students and 3 grades per student in this example. As we did in our prior gradebook example, we're going to take the array that we created here in main and pass it as an argument to the constructor for class gradebook as we build our new gradebook object. Then we're going to tell the object to display its message, and then we're going to tell the object to invoke the process grades method, which will control the rest of the processing and produce the output that we're about to show you. Now I'd like to run this first so I can show you the output to see the type of results you're going to get, and then we'll take a look at how we implemented the functionality in class gradebook. All right, so I'm just going to expand this window for a moment here. You can see that we started out by printing Welcome to the Gradebook for CS 101 Introduction to Java Programming. We output a grid of all the grades, and as part of that grid we show you all the student numbers down the left, the test numbers across the top, and we also showed you the average for each student across all 3 tests. So part of what we're going to do to calculate the average here is pick off one row of information, add the values together, divide by 3, and get the average for each individual student. We also went through the entire gradebook to find the lowest grade across all exams and the highest grade across all exams. And then we went through and did our overall grade distribution once again, showing you all of the grades in the various ranges of numbers that you see here. And again, we didn't have any in the ranges from 0 through 59, but we had several for the ranges 60 to 69, 70 to 79, etc. that we summarized and displayed in a bar chart format. So that's what we'd like to look at, and the question is, how do we get all that information? And we did it by summarizing the values that are in that grades array, or that we pass into the gradebook constructor. So let's take a look at class gradebook now. Once again, we have a string called course name representing the name of the particular gradebook, or the course associated with the gradebook, excuse me. And this time we've declared a two-dimensional array of integers called grades. And again, we're not specifying the sizes. We don't know how many students there are or how many exams there are. So the instructor could have, one class with 10 people and 3 exams and another class with 1,000 people and 10 exams. And this program, the way it's currently set up, will still summarize all the information properly for us. The gradebook constructor receives the name of the class and the array, the two-dimensional array representing all the grades for all the students. We assign each of those parameters to the corresponding instance variable. Set course name, get course name, and display message haven't changed for many iterations of our gradebook class at this point. Now we'll take a look at the process grades method. Process grades is called from main to output the grades, which is also going to calculate the averages for each student, to figure out the minimum and maximum of each grade, and to display the bar chart. So once again, I'd like to look at these various methods in the order that we call them. So I'm going to start with output grades. I'll scroll down towards the bottom here. So here's my output grades method. And you can see that we start out by printing the grades are, and just for simplicity and to align my columns properly, I print out a bunch of spaces as well, and then I output the column heads that indicate the test numbers and eventually the word average as well. So this is simply going to walk through the number of tests that there are, and we figure that out by using grades sub 0 dot length to determine how many columns are in the first row, and we are indeed assuming that every row has the same number of columns in this example, so that is a potential failure point the way we've implemented this example. So for whatever number of grades there are per student, we're going to iterate through that, and we're going to output test and the value that's going to be displayed in this %d location, and the counter test +1 will help me indicate test 1, test 2, test 3. And then after all of those are output, we will simply print the word average followed by a new line character, and that will be the fourth column in my output. Then we have a nested loop here that's going to output all of the grades and the averages for each student. Now for the students, we're going to start counting at 0, and as long as we're less than grades.length, remember this is a two-dimensional array, so grades.length is going to give me the number of rows in that array, which corresponds to the number of students. For each student, we're going to output the string student and a number in a field of 2, right justified. That number will be the value of student +1, so we'll output student numbers from 1 to whatever number of students there are. And for each student, we're going to use an enhanced for loop to walk through the row of grades that represents that particular student's grades. So for every test result in the array grades sub student, I'm going to output a value. Now grades sub student moves me to the particular row of the array that represents a given student, and that really represents a one-dimensional array of grades for that student. I'm going to automatically walk through that array and pick off each value and place it in test, and then display the value of test in a field of 8 characters, right justified. And then finally, before I finish off that row of information, I'm going to calculate the average for one student. I'm going to call getAverage and pass it grades sub student, which again represents one row of the two-dimensional array. So when I go to my getAverage method, which is back up above here, when I go to my getAverage method, you see that it receives a one-dimensional array of integers called setOfGrades, declares a total variable and initializes it to 0, sums up all the grades using an enhanced for statement, and then returns the floating point value of that student's average. We use the double cast operator to convert the integer total to a double, and then a double divided by an int gets converted to a double divided by a double automatically, so I return a double result for my average. Going back down to output grades, once I retrieve that average, I assign it to the variable average and then display the average formatted in a field of 9 characters with 2 digits to the right of the decimal point. Going back up to our process grades method, we can see that the next thing we do are to get the minimum and the maximum grade respectively. And get minimum and get maximum are very similar to what we did in the single or one-dimensional array example. The difference here is that we have to loop through all the rows and columns. So we do a similar set of processing. We first assume that the lowest grade in get minimum is at location 0, 0 of the array, the first row and the first column. Then we use enhanced for loops to walk through all of the array elements and find the lowest grade. So this is kind of interesting. Notice that the variable I'm declaring here in the outer for loop is a one-dimensional array of integers called student grades. And grades, remember, is a two-dimensional array. So what we're saying is for each one-dimensional array of integers in the two-dimensional array grades, I would like to then go and walk through that one-dimensional array one grade at a time, compare the grade to the low grade to see if it's less than the low grade, and if it is, I will assign that grade to low grade. So the key thing here is notice the syntax once again for my control variable, because I'm picking off one row at a time from my two-dimensional array grades. And then as I get to the end of the nested for loop, I'll come back out to the outer loop and do the processing again for the next row, and then at the end I'll return the lowest grade. And if you look at the get maximum method, you see it's basically the same thing, except that we start by assuming that the first element in the multidimensional array is the highest grade, and our if test down here is testing to see if the current grade is greater than the highest grade. The last thing we do back in our process grades method is call output bar chart to show you the bar chart results. And just like we did previously, we're going to use an array frequency to represent the frequency of every range of grades that we encounter. So the first thing we do is we create a nested for loop to summarize those frequencies. The first outer for loop is going to determine which row we're looking at. So we're going to pick off each row as a one-dimensional array of integers from the grades array. Then for the current row we're looking at, we're going to go and take the grade value that's picked out of that row, divide it by 10 to figure out which range it falls into, and then increment the appropriate frequency counter. And then we'll go back and do the same thing for the next row and the next row until there are no more rows to process. And our for loop down here is simply going to output the bar chart, and this part is identical to the prior program. We're going to iterate through all of the elements of the frequency array. If the count is 10, then we're going to output a custom label at the left-hand side. Otherwise, for all the other ones, we're going to output a label that consists of a range of numbers. And then we have a nested for loop to output the proper number of asterisks indicating how many values were in each frequency range. After each row, we display a new line character, and of course, after we finish walking through all the frequencies, we will be done with our bar chart.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.